April 21, 1944. 23,000 feet above Brunswick, Germany. Hauptmann Franz Stigler held his Focke-Wulf 190 at maximum combat power, watching the American bomber formation grow larger in his windscreen. Through the armored glass, he counted 12 Boeing B-17s flying in their characteristic combat box, sunlight glinting off plexiglas turrets and polished aluminum skin. Stigler had destroyed 28 Allied aircraft in 3 years of combat. He understood bomber tactics, knew their blind spots, had perfected the frontal attack that other pilots feared. Yet as he closed to firing range on this crystal-clear spring morning, something made him hesitate. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The bombers weren't evading. They held formation, steady and deliberate, as if daring him to attack. From each fortress, he could see the gun barrels tracking his approach. Chin turrets, cheek guns, top turrets rotating with mechanical precision. The tail gunner in the nearest B-17G had already locked onto him, the twin 50 caliber Brownings following his fighter like the eyes of a predator. Stigler had read the intelligence reports from Rechlin, had attended the tactical briefings, knew the numbers by heart. 13 guns per bomber. 12 bombers meant 156 heavy machine guns pointing outward from that formation. At his current closure rate of 400 miles per hour, he would enter effective range in 8 seconds. The defensive gunners would have perhaps 5 seconds to fire before he flashed past overhead or broke away to avoid collision. 5 seconds didn't sound like much time. The mathematics of what could happen in those 5 seconds made Stigler's throat tighten despite years of combat experience. Each Browning M2 machine gun fired between 750 and 800 rounds per minute. The Americans loaded their ammunition belts with tracers every 5th round, creating visible streams of fire that looked impressive, but more importantly, revealed exactly where their bullets were going. Stigler had watched gun camera footage captured from downed American bombers. He had seen how American gunners walked their fire onto targets, adjusting aim in real time by following the tracer paths. It was effective, brutally so, in ways that German defensive armament on their own bombers had never achieved. He armed his weapons. 4 20mm MG-151 cannons and 2 13mm MG-131 machine guns. 200 rounds per cannon. 400 rounds total for the machine guns. Against a single bomber, this armament was devastating if he could get close enough to use it. Against a formation where every bomber could concentrate fire on his approach corridor, the equation shifted dramatically. The Americans had been bombing Germany in daylight for nearly 2 years now, since the first tentative raids in 1942. Initially, Luftwaffe pilots had approached these missions with confidence bordering on contempt. American bombers, no matter how heavily armed, were still bombers. They couldn't outmaneuver fighters. They couldn't outrun fighters. Their mission required them to fly straight and level toward their targets, predictable as clockwork, while German fighters chose when and how to attack from angles of their own choosing. That contempt had died over the skies of Schweinfurt, Regensburg, and a dozen other German cities where bomber formations had turned the sky into a storm of 50 caliber fire. Luftwaffe after-action reports documented the evolution of American defensive tactics with clinical precision. The isolated bombers of early raids had given way to tight formations where each aircraft's guns supported its neighbors. The 9-gun B-17FS had been replaced by 13-gun B-17GS with chin turrets that eliminated the old frontal attack doctrine's effectiveness. The Americans had learned, adapted, and multiplied their forces faster than German fighter units could compensate. Stigler pressed his attack, knowing hesitation meant failure. The alternative was returning to base having accomplished nothing, explaining to his squadron commander why he had broken off despite perfect weather and a clear tactical setup. At 300 yards, he opened fire, watching his cannon shells arc toward the lead bomber while simultaneously tracking the tracers that began reaching out from the formation toward his fighter. The sky erupted in light. Not the scattered defensive fire he remembered from encounters with British bombers, but a coordinated barrage that seemed to fill the entire space between him and his target. Every bomber in his field of view was firing. Top turrets, tail turrets, waist guns, ball turrets, all converging on the single point in space his fighter occupied. The tracers looked like glowing ropes stretched across the sky, with solid projectiles invisible between each visible round, creating a cone of metal that defied imagination. His fighter shuddered as something struck the wing. A second impact clanged against his armored seat back. The windscreen starred with a spiderweb crack. Stigler broke hard left and down, rolling inverted and diving away from the formation before his brain could fully process what had happened. His fighter was still flying. The engine still ran smoothly. But he had been in the formation's defensive envelope for less than 3 seconds, and in that brief moment, multiple 50-caliber rounds had found his aircraft. As Stigler leveled out 5,000 feet below the bombers and checked his damage, his hands trembled slightly on the control stick. The wing hit had torn through the outer aileron, leaving ragged aluminum edges. The seat armor had stopped what would have been a fatal spine shot. The windscreen crack meant one round had struck dead center, inches from his face, and only the armored glass had prevented his death. He had fired perhaps 30 cannon shells in his single pass. The bombers had fired hundreds, possibly thousands of 50-caliber rounds in response. And the formation continued toward Brunswick, untouched, their defensive barrage having successfully driven off his attack, without any bomber needing to leave formation or take evasive action. This was the reality that German intelligence officers were documenting with increasing alarm through the spring of 1944. The massed defensive firepower of American heavy bomber formations had fundamentally altered the calculus of daylight fighter operations. Understanding how this transformation occurred, why it proved so devastating to Luftwaffe tactics, and what it meant for the air war over Europe required examining not just the weapons themselves, but the industrial philosophy and tactical doctrine that made them so brutally effective. The story of American 50-caliber defensive armament began not in the skies over Germany, but in the development laboratories of John Moses Browning's Connecticut workshops decades earlier. The Browning M2 machine gun, adopted by the United States military in 1933, represented a culmination of machine gun design philosophy that emphasized reliability, rate of fire, and hitting power in a single weapon system. The gun fired the 50 BMG cartridge, a round originally developed for anti-tank rifles in World War I but repurposed for aircraft use in the interwar years. Each bullet weighed roughly 2/3 of an ounce and left the barrel at 2,900 feet per second, carrying kinetic energy exceeding 13,000 foot-pounds. To put this in perspective, German rifle-caliber machine guns firing 7.92 mm rounds produced roughly 1,600 foot-pounds of energy. The American 50 caliber delivered 8 times the hitting power of standard rifle rounds and comparable energy to German 13 mm heavy machine guns. But energy alone didn't explain the 50 caliber's effectiveness. The Browning design achieved remarkable reliability through its recoil-operated mechanism and attention to manufacturing tolerances. Unlike some German aircraft guns that required frequent maintenance and were prone to jamming in cold conditions at high altitude, the Browning M2 functioned consistently across temperature extremes from tropical heat to sub-zero cold at 30,000 feet. This reliability meant American gunners could depend on their weapons working when needed, a psychological advantage difficult to quantify, but absolutely critical in combat. The American decision to standardize on the 50 caliber for bomber defense represented a philosophical choice about how to approach defensive armament. German bombers typically carried a mix of calibers: 7.92 mm rifle caliber guns for lighter positions, 13 mm heavy machine guns for primary defensive locations, and sometimes even 20 mm cannons. This variety complicated logistics, training, and ammunition supply. American bombers carried 50 caliber Brownings exclusively. Every defensive position used the same weapon, fired the same ammunition, and could share spares and training across the entire crew. The simplification allowed for better training specialization. American aerial gunnery schools could focus on mastering a single weapon system rather than familiarizing students with multiple guns. Armored flying schools taught gunners to field strip, maintain, and troubleshoot the Browning M2 until the procedures became automatic. By the time gunners reached operational squadrons in England, they knew their weapon intimately, understood its capabilities and limitations, and could clear jams or malfunctions without conscious thought, even while wearing oxygen masks and heavy gloves at 40 below zero. The ammunition logistics also favored standardization. A.B. B-17G typically carried approximately 7,500 rounds of 50-caliber ammunition distributed across 13 gun positions. Loading this ammunition involved ground crews working in precise coordination to ensure proper distribution. The tail guns received 500 rounds per gun. The waist positions carried 600 to 800 rounds each. The ball turret, despite its cramped quarters, held 500 rounds per gun. The chin turret, cheek guns, and top turret each received ammunition loads calculated to provide sustained defensive fire throughout missions that might last 8 to 10 hours from takeoff to landing. This ammunition load represented significant weight, roughly 2,500 pounds of bullets and brass casings distributed throughout the aircraft. But the Americans had designed the B-17 from the outset to carry this defensive burden. The aircraft's stressed skin construction and robust wing structure could handle the weight while maintaining performance. German bomber designs typically sacrificed defensive armament weight to increase bomb load or extend range, a doctrinal choice that left their bombers more vulnerable but theoretically more effective in their primary mission. The American doctrine prioritized getting bombers to the target and back. A bomber that reached its target, dropped its bombs, and returned to base could fly again tomorrow. A bomber shot down represented not just the loss of the aircraft, but the loss of 10 highly trained crewmen whose replacement required months of training pipeline time. The defensive armament weight was insurance, protection for the most valuable component of the bomber, its crew. By early 1943, when American heavy bomber operations over Europe began in earnest, the B-17F model carried 9 Browning M2 machine guns in positions carefully selected to provide interlocking fields of fire. 2 guns in the tail turret covered the rear hemisphere. 2 guns in the top turret covered approaches from above and behind. 2 guns in the ball turret covered the lower hemisphere. 2 cheek guns operated by the bombardier and navigator provided frontal defense. 1 gun in the radio compartment covered the upper rear quarter. The arrangement left few blind spots, though the nose remained relatively vulnerable to determined frontal attacks. German fighter pilots, studying captured B-17Fs at the Reckland test facility, quickly identified the nose as the weakest defensive zone. The flexible cheek guns, mounted in socket openings in the plexiglas nose glazing, had limited traverse and required crew members to physically move the guns from one socket to another. The bombardier and navigator, who manned these guns, had other primary duties during the bombing run and weren't dedicated gunners like the tail or ball turret positions. Hauptmann Egon Mayer of Jageschwader II pioneered the frontal attack doctrine in late 1942. His tactical innovation recognized that approaching from 12 o'clock high, diving slightly from above and ahead, allowed a fighter to bore in on the bomber's weakest defensive zone while maximizing the fighter's own firepower concentration. The combined closing speed of fighter and bomber exceeded 500 miles per hour, giving defensive gunners perhaps 2 seconds to acquire, track, and engage before the fighter flashed past. Those 2 seconds demanded extraordinary skill from the bomber's nose gunners. They had to track a rapidly approaching target growing larger by the instant, estimate the correct lead angle while accounting for their own aircraft's motion and the target's speed, and fire accurately despite wind blast, vibration, and the psychological pressure of watching a fighter dive directly toward them with guns blazing. Most critically, they had to accomplish this while the fighter pilot enjoyed a nearly stationary target in his gun sight. Deflection shooting, tracking a crossing target and leading it correctly, was one of the most difficult skills in aerial gunnery. The frontal attack largely eliminated deflection, reducing the attack to simple point-and-shoot marksmanship. The tactic worked devastatingly well when executed by skilled pilots. German aces who mastered the head-on pass achieved impressive kill ratios through early 1943. Luftwaffe tactical bulletins circulated through fighter units across Germany and occupied Europe, documenting the technique's effectiveness and training new pilots in its execution. For several months, frontal attacks represented the greatest threat to American bomber formations, more dangerous than flak, more deadly than any other fighter tactic. The American response was characteristically industrial. Rather than relying on better-trained gunners or tactical adjustments to compensate for the B-17F's nose vulnerability, Boeing and the Army Air Force's engineering staff designed a solution that added weight and complexity but eliminated the problem entirely. The B-17G model, entering production in summer 1943, mounted a new chin turret directly beneath the nose. This powered turret, similar in concept to the ball turret, carried two 50 caliber Brownings controlled remotely by the bombardier through a computing gun sight. The chin turret transformed the B-17's frontal defense from its weakest point to one of its strongest. The bombardier could now track attacking fighters from first detection at long range, bringing two guns to bear throughout the fighter's approach. Combined with the existing cheek guns and the top turret, which could rotate forward to add its two guns to the defensive barrage, a B-17G could bring 6 to 8 heavy machine guns to bear on a frontal attacker. This concentration of fire created a defensive cone that required exceptional skill and iron nerve to penetrate. German fighter pilots discovered this change the hard way. The frontal attack that had been the preferred tactic of aces suddenly became far more dangerous. Fighters approaching from 12 o'clock now faced sustained fire from multiple weapons throughout their approach. The psychological impact was immediate and devastating to Luftwaffe effectiveness. Pilots who had successfully used frontal attacks against F models found themselves breaking off prematurely when facing G models, their survival instincts overriding tactical discipline when faced with the wall of tracers reaching out from the target bomber. The mathematics of defensive firepower grew even more daunting when considering formation tactics. American doctrine never sent bombers individually against German targets. The combat box formation, refined through painful experience over German skies, positioned bombers in tight three-dimensional arrays where each aircraft's guns supported its neighbors. A typical squadron element contained 3 aircraft flying in close formation. 3 squadron elements stacked vertically and offset horizontally formed a squadron box of 9 bombers. 3 squadron boxes formed a group box of 27 to 36 aircraft, depending on attrition and maintenance status. The defensive firepower calculation for a full group box was staggering. Assuming 27 B-17Gs, each carrying 13 50 caliber machine guns, the formation possessed 351 heavy machine guns providing interlocking fire. Not all guns could engage a single target simultaneously due to traverse limits and aircraft positioning. But a German fighter attacking the formation's leading edge might face fire from 30 to 50 machine guns converging on its flight path. At 750 rounds per minute per gun, 30 guns firing simultaneously through 375 rounds per second into the approach corridor. In the 5 seconds a fighter might be within effective range during an attack run, those 30 guns would fire over 1,850 caliber rounds. The individual hit probability for any single round might be low, perhaps 1 to 2% given the difficulties of deflection shooting at long range. But 1,800 attempts created near certainty that some rounds would find the target. Luftwaffe combat reports from 1943 and early 1944 documented this brutal arithmetic with clinical precision. Fighter pilots described approaching formations as flying into a storm of steel. The tracers, loaded every 5th round to help gunners adjust their aim, created visible streams that seemed to fill the entire sky. For every tracer, 4 invisible rounds followed the same path. The psychological impact of seeing these glowing ropes of fire converging from multiple bombers simultaneously often broke pilots' concentration before physical damage occurred. Many Luftwaffe pilots broke off attacks early, their survival instincts overriding tactical discipline when faced with the visual spectacle of mass defensive fire. Post-war studies analyzing gun camera footage and pilot debriefings revealed that psychological deterrence accounted for as much defensive effectiveness as actual hits. The sight of tracers forced pilots to take evasive action, disrupting their aim and reducing time on target. Even attacks that continued to firing range often suffered from degraded accuracy because pilots flinched or adjusted course to avoid perceived threats rather than maintaining perfect track on their targets. The education of the Luftwaffe regarding American defensive firepower came through a series of increasingly costly lessons that no amount of training could adequately prepare pilots for. The classroom instruction at fighter schools across Germany taught aircraft recognition, attack angles, deflection shooting techniques, and the theoretical vulnerabilities of bomber formations. But theory collapsed when confronted with the reality of 300 machine guns firing simultaneously from a formation that seemed to fill half the sky. Lieutenant Wilhelm Unger experienced this education on May 14, 1944, during an interception mission against bombers targeting oil refineries at Politz. His Messerschmitt Bf 109 G6 climbed through scattered clouds at 28,000 feet. Part of a staffel of 12 fighters scrambled to intercept an American formation reported at 30,000 feet. Through breaks in the cloud cover, Unger could see them, a massive box of perhaps 40 bombers catching the afternoon sun like a school of metallic fish suspended in the crystal-clear air. The staffel leader ordered a coordinated attack from 3 o'clock high, diving from altitude to build speed before entering the formation's defensive envelope. Unger followed his element leader into the attack, watching the bombers grow larger as his fighter accelerated past 400 miles per hour in the dive. At 2,000 yards, he could distinguish individual aircraft types. B-17GS, the newer variant with the chin turret. At 1,500 yards, he saw the turrets beginning to track his approach. Gun barrels swung in mechanical unison, multiple weapons from multiple bombers, all orienting toward the diving fighters. At 1,000 yards, the sky caught fire. Unger had seen defensive fire before during attacks on British bombers and earlier encounters with American formations. This was different in scale and intensity. The tracers didn't come in scattered bursts, but in continuous streams, glowing lines that seemed to reach out from every bomber simultaneously. His training had emphasized smooth, steady tracking during the attack run. Hold the target in the gun sight. Compensate for closure rate. Fire at 400 yards and break away at 200 to avoid collision. The training hadn't prepared him for the instinctive terror of watching those tracer streams converge on his aircraft. Every rational thought screamed that he was flying into certain death, that no aircraft could survive passage through that concentration of fire. His hands wanted to break away, to roll out of the attack and dive for safety. Only pride and discipline kept him on course as the distance closed from 1,000 yards to 800 to 600. At 500 yards, something struck his fighter with a sound like a hammer blow against sheet metal. Then another impact. And another. The canopy splintered, throwing plexiglas fragments that stung his face through his oxygen mask. The engine coughed, RPMs fluctuating as coolant temperature spiked red. Unger fired his weapons, seeing his cannon shells arc toward the nearest bomber, but he had no idea if they hit. His entire focus had narrowed to the tracer streams that seemed to be physically pushing his fighter away from the formation. He broke left and down, diving away with the engine now streaming white coolant vapor that crystallized instantly in the frigid air. Behind him, the bomber formation continued on course, their defensive barrage having successfully driven off the attack. Unger's fighter limped back to base on partial power, the engine running rough from battle damage. Post-flight inspection revealed 14 separate 50-caliber hits. The armor plate behind his seat had stopped 3 rounds. His rudder had been holed twice. The cooling system had taken multiple hits. Any one of a dozen bullets could have killed him, and he had been in the defensive envelope for perhaps 4 seconds. That evening, Unger wrote in his journal about the experience, trying to capture what it felt like to attack a formation bristling with hundreds of machine guns. He struggled to find adequate words. The tracers were mesmerizing, terrifying, hypnotic. They created a visible barrier that seemed impenetrable. The sound of rounds striking his fighter, sharp metallic bangs that he felt through the airframe as much as heard, had triggered a primal fear response that training couldn't suppress. He had broken off his attack early, before reaching optimal firing position, because continuing seemed suicidal. Reading his account decades later provides insight into the psychological dimension of mass defensive fire. The Americans had created a weapon system that was as much psychological as physical. The visible tracers served partially as aiming references for gunners, but they also served as deterrents to attacking fighters. Seeing the volume of fire coming toward you, watching those glowing streams converge on your aircraft, created a mental pressure that was nearly impossible to resist. Many pilots broke off attacks without taking significant damage, driven away by the perception of lethal danger rather than actual hits. The Luftwaffe's tactical response to this defensive firepower evolved through trial and painful error. The old doctrines, developed against less heavily armed British bombers and pre-war assumptions about defensive capabilities, proved increasingly inadequate. Fighter commanders across Germany and occupied Europe developed new approaches, sharing hard-won lessons through tactical bulletins and training programs. One adaptation involved attacking from extreme angles where fewer guns could be brought to bear. Diving attacks from above and behind, properly called 12 o'clock high attacks, approached the formation from a direction where the ball turrets couldn't reach and top turrets had limited elevation. This required exceptional altitude advantage, typically 5,000 to 7,000 feet above the bomber formation, and demanded precise dive angles to remain in the attack window. Too steep and the fighter would overshoot. Too shallow and it would enter the envelope of top turret fire. Another tactic emphasized standing off beyond machine gun effective range and using long-range weapons. The Werfer Granit 21-centimeter rocket, carried in underwing tubes, could theoretically engage bombers from 1,200 yards, beyond the effective range where 50 caliber fire maintained lethal energy. These unguided rockets carried large high-explosive warheads intended to break up formations through blast effect rather than achieve direct hits. A rocket exploding within a combat box might damage multiple bombers through fragmentation or cause collisions as pilots took violent evasive action. In practice, the rockets proved nearly as frustrating as the direct attacks they were meant to replace. The projectiles had poor ballistic characteristics, making accurate aim extremely difficult beyond 800 yards. The underwing tubes created substantial drag that reduced fighter performance by 10 to 15%, making the launching fighter vulnerable to American escort fighters. Most critically, fighters carrying rockets became priority targets for the P-51 Mustangs and P-47 Thunderbolts that increasingly accompanied bomber formations deep into Germany. By late 1944, American fighters could escort bombers all the way to Berlin and back, eliminating the sanctuary that German fighters had previously enjoyed in the Reich's interior. This changed the tactical equation fundamentally. German fighters now had to defeat or evade American escorts before they could even attempt attacks on bomber formations. And if they did reach the bombers, they faced the concentrated defensive fire that had already proven so deadly. The numerical attrition ground down Luftwaffe fighter strength through 1944. Every loss, whether to defensive fire or escort fighters, removed an experienced pilot whose replacement typically had far less training and combat experience. The average flight time for new Luftwaffe pilots decreased steadily through the war's final years as fuel shortages, training aircraft losses, and the accelerating demand for replacements compressed training programs. By early 1945, some fighter pilots arrived at operational squadrons with less than 200 hours total flight time and minimal gunnery training. These inexperienced pilots faced veteran American bomber crews whose training had become systematically refined through 2 years of combat experience. The Army Air Force's rotated combat crews back to training commands in the United States after completing their tour requirements, initially 25 missions, later extended to 35. These veterans became instructors, passing hard-won combat knowledge to new crews. The institutional learning created a force multiplier effect where each generation of bomber crews benefited from the experiences of those who had gone before. German fighter training, by contrast, had collapsed under the weight of fuel shortages, Allied air superiority over training areas, and the desperate need to rush replacements to frontline units. New pilots often receive their first combat experience with minimal preparation, flying 1 or 2 missions before being killed or so badly shaken that their effectiveness was compromised. The survivors gained experience rapidly, but the survivor population grew steadily smaller as attrition overwhelmed the replacement system. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The defensive firepower that American bombers brought to bear represented only one element of a comprehensive system designed to project strategic bombing capability deep into enemy territory despite determined opposition. The 50 caliber Brownings were the visible manifestation of a deeper American advantage in industrial organization, tactical doctrine, and operational sustainability. Consider the ammunition supply chain required to keep those guns fed. A single B-17G carrying 7,500 rounds of 50 caliber ammunition represented the output of American factories that produced hundreds of millions of rounds monthly. The Lake City Army Ammunition Plant in Missouri alone manufactured over 4 million rounds of 50 caliber ammunition per day at peak production. This single facility's daily output could supply approximately 530 bombers with complete ammunition loads. The United States operated multiple ammunition plants of similar scale, creating a supply system that could sustain operational losses that would have crippled German logistics. When bombers returned from missions with their ammunition expended, ground crews could reload them within hours because the supply chain ensured ammunition availability. The logistics tail that supported combat operations extended back through supply depots in England, across the Atlantic to American ports, and ultimately to the factories where workers on assembly lines produced the components that fed the combat machine. This industrial depth manifested in every aspect of bomber operations. When aircraft suffered battle damage, repair depots in England could access a parts inventory containing thousands of standardized components. Major damage that might have rendered a German bomber unsalvageable could be repaired by American depot teams who could swap entire sections of airframe, replace damaged engines, and return aircraft to combat-ready status within weeks. The Americans had designed their bombers for maintainability, with panels and components that could be removed and replaced quickly using standard tools. German bomber designs, by contrast, often required custom fitting of components and skilled craftsmen to perform major repairs. As the war progressed and Allied bombing disrupted German industry, the quality of German aircraft construction declined noticeably. Captured German aircraft examined by Allied intelligence teams showed rough workmanship, mismatched panels, and improvised repairs using non-standard materials. The contrast with American manufacturing quality was stark and revealing. The Reckland Test Facility's examination of captured B-17s had documented this manufacturing philosophy in detail. German engineers who studied the bombers noted with professional admiration how every design decision reflected optimization for mass production. Standardized fasteners throughout the aircraft reduced inventory requirements. Straight panels with minimal compound curves simplified forming operations. Modular subassemblies allowed parallel construction of fuselage sections, wings, and tail surfaces that came together in final assembly with minimal custom fitting required. This approach enabled Boeing's Seattle plant to complete one B-17 every hour at peak production rates in 1944. That single factory's output exceeded Germany's total four-engine bomber production for the entire war. When combined with Douglas and Vega plants also producing B-17s, plus the even greater numbers of B-24 Liberators being manufactured at Ford's Willow Run facility and other plants, American heavy bomber production reached levels that seemed impossible to German observers but proved conservative in hindsight. The implications were strategic and devastating. Even if Luftwaffe fighters achieved favorable loss ratios in combat, shooting down 2 or 3 bombers for every fighter lost, American industry could sustain such attrition indefinitely. Germany could not. By mid-1944, this arithmetic had become undeniable even to the most optimistic German planners. The question was no longer whether Germany could win the air war over Europe, but how long German forces could continue fighting against increasingly overwhelming material disadvantage before collapse became inevitable. The human cost of confronting massed 50 caliber defensive fire accumulated in Luftwaffe casualty reports through 1944. Fighter pilot losses climbed steadily as American bomber streams grew larger and more frequent. The missions that had once been occasional events, a raid every few days that could be met with concentrated defensive effort, became daily occurrences. Sometimes multiple raids per day, targeting different cities simultaneously to fragment German defensive responses. Oberleutnant Heinrich Sturm flew 3 missions on June 20, 1944, a day that became burned into his memory as emblematic of the hopelessness that was spreading through fighter units. The first mission launched at dawn, intercepting bombers targeting oil facilities at Merseburg. His Gruppe made one attack pass before American P-51s intervened, shooting down 4 German fighters and forcing the rest to break off. The second mission, early afternoon, targeted bombers returning from Munich. Again, a single attack pass before escorts engaged. The third mission, early evening, scrambled to intercept a formation of what turned out to be B-24 24 liberators attacking marshalling yards at Leipzig. Sturm's fighter had been refueled and rearmed between each mission, but he hadn't eaten and had slept perhaps 2 hours the previous night. His hands shook from exhaustion as he strapped into the cockpit for the third sortie. During the attack on the liberators, he fired his weapons but had no clear memory of aiming. The tracers coming from the bombers seemed to fill his entire vision. He broke away early, his ammunition expended, having no idea if he had hit anything. That evening, the squadron assembled for debrief. Of the 18 fighters that had flown that day, 5 hadn't returned. 3 pilots were confirmed dead. 2 were missing, their fates unknown. The squadron claimed 7 bombers destroyed, though post-war records would show only 3 American bombers lost that day from all causes in the relevant areas. The discrepancy between claimed and actual kills had become a chronic problem, multiple pilots often claiming the same bomber, or damage being mistaken for fatal hits. What Sturm remembered most clearly from that day was the overwhelming sense of futility. His unit had flown 3 maximum effort missions. They had lost 5 aircraft and 3 pilots. The bombers had continued to their targets, dropped their bombs, and those that survived would return tomorrow. And the day after. And the day after that. There was no end visible, no indication that the bleeding could be stopped. The psychological impact of facing this endless attrition manifested in various ways across Luftwaffe fighter units. Some pilots developed fatalistic attitudes, flying aggressively because survival seemed impossible regardless of caution. Others became increasingly cautious, breaking off attacks earlier, claiming engine trouble or equipment malfunctions to avoid combat. Unit cohesion began fragmenting as experienced pilots who had survived months of combat watched new replacements die on their first or second missions. The defensive firepower was only part of the problem, but it was the most visible and psychologically impactful part. The other threats, escorts, flak, mechanical failure, could be rationalized or compartmentalized. But the wall of tracers coming from a bomber formation was impossible to ignore, impossible to dismiss. Every attack meant flying directly into that fire, watching it converge on your aircraft, knowing that mathematics and probability meant eventually your luck would run out. Hauptmann Heinz Nock, commanding officer of a fighter group based near Hanover, wrote extensively in his diary about the psychological toll. He described pilots who developed physical symptoms, shaking hands, nervous tics, inability to sleep, after particularly intense combat. The Luftwaffe's medical services had no adequate treatment for what would later be recognized as combat stress reaction. Pilots who couldn't fly were often simply removed from flight status and reassigned to ground duties, their combat experience lost to units that desperately needed every experienced pilot. The Americans, meanwhile, had developed systematic approaches to managing combat stress. Crew rotation policies ensured that men weren't ground down indefinitely. Flight surgeons monitored crews for signs of psychological strain. The rest and recuperation system provided breaks from combat operations. Most importantly, there was an endpoint. Complete 25 missions, later 35, and you went home. Survive long enough, and you were done. This gave crews something concrete to work toward, a finish line that made the daily danger bearable. German fighter pilots had no such endpoint. You flew until you died, were captured, or became physically incapable of continuing. The few pilots who survived long enough to accumulate very high victory totals, men like Erich Hartmann with 352 confirmed kills, were exceptions whose survival was partially skill, partially luck, and partially the result of flying primarily on the Eastern Front where conditions differed significantly from the defensive fire they would have faced over Germany. The technological race continued through late 1944 as both sides sought advantages. The Luftwaffe introduced the Messerschmitt Me 262 jet fighter, the world's first operational jet-powered fighter aircraft. This revolutionary design could outrun any American escort fighter, achieving speeds over 500 miles per hour. Its 4 30mm Mk-108 cannons delivered devastating hitting power. Against bomber formations, the 262 could theoretically close rapidly, fire, and escape before defensive guns could track it effectively. In practice, the jet's advantages were offset by critical vulnerabilities. The aircraft was extremely vulnerable during takeoff and landing when its speed advantage didn't exist. American fighters learned to patrol German airfields, attacking jets as they returned with fuel exhausted and ammunition expended. The jet engines were temperamental and required frequent maintenance by skilled technicians. Fuel consumption was enormous, and Germany's collapsing fuel production system couldn't provide adequate supplies for large-scale jet operations. Most significantly, the jets arrived too late and in too few numbers to affect the strategic outcome. Several hundred Me-262s were eventually built, but mechanical problems, fuel shortages, and pilot inexperience meant only a fraction were operational at any given time. Even the most optimistic assessments suggested jets accounted for fewer than 100 bomber kills total, a negligible impact on operations involving thousands of bombers. The massed 50 caliber defensive fire continued its grinding work through the winter of 1944 and into 1945. Bomber formations grew larger as American production outpaced losses. By early 1945, formations of 800 to 1,000 bombers were not uncommon, escorted by equal numbers of fighters. These massive raids represented aerial firepower on a scale that defied comprehension. 1,000 B-17s carried 13,000 heavy machine guns. If even 10% of those guns engaged a single target simultaneously, that target faced fire from 1,300 machine guns throwing over 16,000 rounds per minute into the airspace it occupied. No amount of pilot skill or courage could overcome such odds. The air war over Germany became increasingly one-sided as Luftwaffe fighter strength collapsed under accumulated losses, fuel shortages, and the destruction of training infrastructure. By April 1945, organized fighter resistance had largely ceased. The bombers flew their missions with minimal opposition, their defensive guns silent for lack of targets. The final accounting of what massed 50 caliber defensive fire meant to the air war emerged gradually through post-war analysis. The United States Strategic Bombing Survey, conducted immediately after Germany's surrender, compiled comprehensive data on bomber operations, losses, and effectiveness. The statistics told a story of overwhelming material advantage translated into strategic success through systematic application over time. American heavy bomber forces, primarily B-17s and B-24s, flew over 900,000 sorties over Europe between 1942 and 1945. They dropped over 1.5 million tons of bombs on German targets, systematically destroying oil production facilities, transportation networks, aircraft factories, and cities. The campaign cost approximately 18,000 heavy bombers lost to all causes, combat, and accidents. This represented roughly 20% of total production, a sustainable loss rate given American industrial capacity. The bomber crews manning these aircraft suffered terribly. Of the roughly 350,000 Army Air Forces personnel who served in 8th and 15th Air Forces bomber units, over 50,000 became casualties, killed, wounded, or captured. The casualty rate for bomber crews exceeded that of infantry units in many cases, making it one of the war's most dangerous assignments. Yet the replacement pipeline ensured that losses, while tragic, didn't prevent sustained operations. The defensive armament's effectiveness could be measured through German fighter loss rates when attacking bomber formations. Luftwaffe records, cross-referenced with American loss reports, suggested that German fighters had roughly a 1 in 3 chance of being shot down or damaged when pressing attacks home against defended formations. This included losses to both defensive fire and escort fighters. But the mass guns contributed significantly to the overall threat environment that made bomber interception so costly. The psychological impact was harder to quantify, but arguably more important. The visible deterrent effect of hundreds of guns firing simultaneously caused many attack attempts to be broken off prematurely or never pressed with full commitment. Post-war interrogations of Luftwaffe pilots revealed that many had developed deep respect bordering on fear for American defensive firepower. Several former aces admitted that attacking a full bomber formation in 1944 required more courage than any other combat mission they had flown. The defensive philosophy that emphasized massed firepower over any other consideration had proven itself through sustained operations against determined opposition. The Americans had accepted the weight penalty of carrying thousands of rounds of ammunition and 13 guns per bomber. They had accepted the complexity of training specialized gunners and maintaining sophisticated turret systems. They had accepted the industrial challenge of producing millions of rounds of 50 caliber ammunition monthly. In exchange, they had created a weapons system that could survive in hostile airspace despite facing some of the world's best fighter pilots flying capable aircraft. The bombers completed their missions. They destroyed their targets. And enough survived each mission to continue the campaign day after day, month after month, until Germany's industrial capacity and military resistance collapsed. The education that Hauptmann Franz Stigler received on April 21, 1944, above Brunswick, became a lesson he would carry for the rest of his life. The damaged Focke-Wulf 190 that brought him back to base that afternoon bore testament to what 3 seconds of exposure to massed 50 caliber fire could accomplish. His ground crew counted the hits in silence, their faces reflecting the same grim understanding that was spreading through fighter units across Germany. 14 separate strikes. Any one of them could have been fatal. The wing hit that tore through his aileron had missed the main spar by inches. Had it struck 6 inches inboard, the wing structure might have failed, sending his fighter tumbling out of control. The rounds that hit his armored seat back had been fired from directly behind, meaning a ball turret gunner had tracked him perfectly during his breakaway dive. The windscreen strike dead center represented marksmanship or luck, depending on perspective, but either way, it demonstrated that American gunners were hitting targets that were maneuvering violently at high speed. Stigler wrote a detailed after-action report that evening, trying to capture the experience for intelligence officers who were compiling data on American defensive tactics. He struggled with the same challenge that Wilhelm Unger and countless other pilots faced when attempting to describe what it felt like to attack a fully alerted bomber formation. The tracers created a visual barrier that seemed physical, a wall you had to force yourself to penetrate despite every survival instinct screaming warnings. The sound of impacts, metal striking metal at supersonic velocity, triggered primal fear responses that training could prepare you for but never fully suppress. His report concluded with an assessment that would be echoed in hundreds of similar documents flowing to Luftwaffe headquarters through 1944. Frontal attacks against B-17G formations equipped with chin turrets are tactically unsound unless executed by highly experienced pilots under ideal conditions. The defensive firepower concentration, particularly from lead aircraft in the formation, creates an engagement envelope where fighter survival depends more on fortune than skill. Recommend development of standoff weapons or alternative tactics that minimize exposure time. The recommendation was sound. The implementation was impossible. Germany lacked the industrial capacity, fuel supplies, and time to develop and deploy effective standoff weapons in numbers sufficient to matter. The few weapons that were developed, rockets, air-to-air bombs, even experiments with guided missiles, arrived too late or in too few numbers to affect outcomes. The Luftwaffe was left fighting with conventional tactics against an opponent whose defensive systems had been specifically designed to defeat those tactics. The captured B-17s that German test pilots flew at Rechlin provided invaluable technical intelligence, but they also served as stark reminders of the industrial gap that Germany could never close. Hans Werner Lurch, the test pilot who had flown the captured B-17F known as Wolfhound extensively through 1943, later wrote that every hour he spent in American aircraft reinforced his conviction that Germany had lost the war by 1943 based purely on industrial mathematics. Lurch's post-war memoirs described sitting in the B-17's cockpit, studying the instrument panel and controls, and recognizing a manufacturing philosophy fundamentally different from German practice. The Americans had optimized every aspect of the design for production volume. Standardized gauges, simplified switch layouts, modular assemblies that could be manufactured at different factories and transported to final assembly sites. Everything about the bomber screamed mass production in ways that German aircraft designs never achieved. He flew the captured Fortress dozens of times, evaluating its handling characteristics, testing its defensive gun positions from the attacker's perspective, and studying the interlocking fields of fire that made it so difficult to attack successfully. During one memorable test flight, Lurch sat in the tail gunner position while another German pilot flew a Messerschmitt Bf 109 in simulated attack passes. The experience was revelatory and disturbing. From the tail turret, Lurk could track the attacking fighter throughout its approach from first visual acquisition at over 2,000 yards to breakaway at 200 yards. The powered turret responded smoothly to his control inputs, swinging the twin 50 caliber Brownings to follow the target with mechanical precision. The optical computing gun sight helped him calculate the correct lead angle, displaying where his bullets would go if he fired at that instant. The gun triggers were positioned naturally under his thumbs, requiring minimal hand movement to engage. Most impressively, the entire system worked reliably in conditions that would have grounded German bombers. Lurk flew these test missions at altitudes exceeding 25,000 feet, where temperatures dropped to 40 degrees below zero. The Brownings functioned flawlessly. The turret motors didn't freeze. The ammunition feeds didn't jam. The oxygen system provided adequate flow. An American tail gunner could remain in that position for hours during actual combat missions, maintaining full defensive capability throughout the flight. Lurk's report to Luftwaffe headquarters noted that German defensive armament installations rarely achieved such reliability. Gun positions on German bombers were often improvised, cramped, and suffered from mechanical problems in extreme conditions. Ammunition feeds jammed. Motors froze at altitude. Gunners struggled with inadequate oxygen supplies and poor visibility. The disparity wasn't just in the number of guns carried, but in the entire system design philosophy that made American defensive armament consistently reliable while German equivalents proved temperamental. The intelligence value of these captured bombers extended beyond technical specifications. German fighter pilots who trained against the captured B-17s at Rechlin learned to identify genuine blind spots where attacking fighters could minimize exposure to defensive fire. They practiced approach angles and breakaway techniques that offered the best survival odds. They studied the timing required to penetrate the defensive envelope, fire effectively, and escape before concentrated return fire could inflict fatal damage. But this hard-won knowledge couldn't change the fundamental arithmetic. Understanding where the blind spots were didn't create more blind spots. Knowing the optimal attack angles didn't reduce the number of guns that could engage from those angles. And most critically, individual pilot skill couldn't compensate for the numerical advantage that American formations brought to every engagement. By late 1944, the experienced pilots who had learned these tactics at Rechlin or through hard combat experience were increasingly rare. The average Luftwaffe fighter pilot in the war's final year had minimal training, limited flight hours, and virtually no combat experience before his first mission. These novice pilots faced veteran American bomber crews whose gunners had survived dozens of missions, knew their weapons intimately, and had developed the muscle memory and spatial awareness that came from prolonged exposure to combat conditions. The quality gap manifested in engagement outcomes. Experienced German aces could still achieve impressive results when they managed to intercept bombers without escort interference. But the overall effectiveness of Luftwaffe fighter forces declined steadily as attrition removed veterans faster than the training system could replace them. The 50 caliber defensive fire that experienced pilots had learned to respect and avoid when possible proved absolutely devastating to inexperienced pilots who lacked the judgment to break off attacks before entering the most lethal zones. The final major air battle over Germany occurred on April 7, 1945, when over 1,000 American heavy bombers attacked various targets across what remained of the Third Reich. Luftwaffe resistance was minimal and disorganized. Fuel shortages had grounded most fighter units. The survivors who did scramble encountered bomber formations so large that any meaningful opposition seemed futile. Oberleutnant Heinrich Sturm, who had flown 3 missions in a single day back in June 1944, was among the few pilots who managed to get airborne that day. His unit, reduced to 6 flyable aircraft from the 36 it had possessed 10 months earlier, intercepted a formation of B-17s south of Berlin. Sturm made a single half-hearted pass, fired his weapons without any real expectation of hitting, and broke away when tracers began reaching toward his fighter. He landed with ammunition remaining, the first time in months he had returned from combat without expending his full load. There seemed no point in pressing attacks that couldn't affect the outcome. The war was lost. Everyone knew it, though saying so openly remained dangerous. The bombers would continue coming until Germany surrendered or was physically occupied. The defensive firepower that had seemed impressive in 1942 had become merely routine by 1945, one more insurmountable obstacle in a strategic situation that had become hopeless. Germany surrendered on May 8, 1945. The guns fell silent across Europe. In the immediate aftermath, American intelligence teams fanned out across occupied Germany, interviewing captured Luftwaffe personnel and examining records. The debriefings of fighter pilots provided remarkable insights into the German perspective on American defensive tactics and the effectiveness of massed 50 caliber fire. General Adolf Galland, former general of fighters who had commanded Luftwaffe fighter forces through much of the war, provided extensive testimony to American interrogators. His assessments were blunt and professional, unburdened by the propaganda requirements that had shaped his wartime statements. Galland acknowledged that American defensive firepower had fundamentally altered the tactical equation of daylight bomber operations. He calculated that attacking a full combat box formation of 27 B-17s required accepting approximately 30% casualty rates among attacking fighters, even when executed by experienced pilots using optimal tactics. This loss rate was simply unsustainable given German production limitations and training pipeline constraints. For comparison, submarine forces typically withdrew from operational areas when loss rates exceeded 10%, considering such attrition unacceptable for sustained operations. Galland noted that individual American bombers were not particularly difficult to destroy if a fighter could achieve proper firing position without interference. The B-17's construction, while robust, could be penetrated by German cannon fire. Concentrated fire into engines, cockpit, or fuel tanks would bring down any bomber given sufficient time and ammunition. The problem was achieving that firing position against formations where dozens of machine guns could concentrate fire on attacking fighters throughout their approach. He estimated that the defensive firepower accounted for approximately 40% of Luftwaffe fighter losses when attacking bomber formations, with American escort fighters responsible for the remaining 60%. But these percentages interacted in ways that made the overall problem worse than simple addition suggested. The defensive fire forced German pilots to take evasive action, extend their attacks, or break off prematurely. This extended the time fighters remained vulnerable to escorts and reduced the number of bombers they could engage before exhausting ammunition or fuel. The escort fighters, meanwhile, learned to exploit the bombers' defensive fire. American fighter pilots would position themselves to drive German fighters toward bomber formations, essentially using the massed 50 caliber guns as anvils against which they could hammer pursuing opponents. A German fighter fleeing from an American P-51 might find itself forced into the defensive envelope of a bomber formation, taking fire from both the pursuing escort and the bombers it flew past. This combination of defensive and escort firepower created a tactical environment where German fighters were never safe, never able to focus exclusively on either threat. The psychological pressure of facing multiple simultaneous dangers degraded combat effectiveness even among experienced pilots and proved overwhelming for novices. Galland's assessment concluded that by mid-1944, the air battle over Germany had become unwinnable for the Luftwaffe regardless of tactical adjustments or technological improvements. The human stories behind the statistics emerged gradually through post-war years as veterans from both sides began sharing their experiences. The American gunners who had manned those 13 positions in each B-17G had their own perspectives on the defensive firepower they wielded. Staff Sergeant Michael Russo, who served as a ball turret gunner through 35 missions with the 91st Bomb Group, provided oral history interviews decades after the war that captured the gunner's view of these air battles. Russo described the ball turret position as simultaneously the best and worst place on the bomber. The spherical turret provided unobstructed visibility of the lower hemisphere, allowing him to track targets throughout their approach from below. The twin 50 caliber Brownings gave him hitting power comparable to any other position. The computing gun sight helped calculate proper lead angles for deflection shots. But the position was also impossibly cramped, requiring Russo to curl into a fetal position for hours at a time while wearing an oxygen mask, heated suit, and parachute harness. The parachute situation particularly troubled him. The ball turret was too small to accommodate a parachute, so gunners left their chutes inside the fuselage, and would have to rotate the turret to the access position and climb out before bailing out if the aircraft was hit. This required time and a functioning turret rotation mechanism. If the hydraulics were damaged or the turret jammed, the ball turret gunner was trapped. Several ball turret gunners died when their bombers made emergency landings with the turret jammed in the down position, crushed when the fuselage belly contacted the ground. Despite these dangers, Russo felt that manning the ball turret gave him more control over his survival than positions like waist gunner where you stood at an open window with no protection. In the ball turret, he had armor plating, clear fields of fire, and the ability to engage targets early in their approach. He estimated he had fired over 20,000 rounds during his combat tour, though he could only confirm one probable kill on a Focke-Wulf 190 that he hit during a climbing attack from below. The confirmation problem plagued gunner assessments throughout the war. Multiple gunners would engage the same target, making it nearly impossible to determine whose fire actually caused the kill. Gun camera footage helped, but couldn't always provide definitive proof. Post-war analysis suggested that only about 10 to 15% of claimed kills could be definitively confirmed through correlation with German loss records. This didn't mean the other claims were fraudulent, just that the confusion of combat made accurate assessment impossible. What Russo remembered most vividly was the sound and feel of the guns firing. The Browning M2S had a distinctive rhythm, a hammering cadence that you felt through the turret structure as much as heard through your headset. When all 13 guns in the bomber fired simultaneously, the vibration was intense enough to make vision blur slightly. During major battles, when his entire formation engaged attacking fighters, the sustained firing created a continuous roar that overwhelmed even the engine noise that normally dominated the sonic environment. He described watching tracers from dozens of bombers converge on single fighters and understanding why German pilots often broke off attacks prematurely. The visual effect was overwhelming even from inside the formation. From the attacker's perspective, it must have seemed like flying into a solid wall of fire. Russo admitted he felt something approaching pity for German pilots who pressed their attacks home despite the barrage. It took immense courage to continue flying directly toward guns that were clearly hitting around and on your aircraft. The German pilots who survived the war had their own complex relationships with the memory of facing American defensive fire. Wilhelm Unger, whose May 1944 encounter had nearly killed him, eventually immigrated to the United States in the 1950s and settled in California. He occasionally attended airshow events where restored B-17s were displayed, drawn by complicated feelings toward the aircraft that had almost ended his life. At one such event in 1973, Unger met a former B-17 pilot who had flew missions over Germany during the same period. The two men talked for hours, comparing perspectives on the air war from opposite sides. The American pilot, Captain James Sullivan, described what it felt like inside a bomber formation under attack, the constant fear of fighter passes, the helplessness of sitting in the cockpit while gunners fought off attackers, the sick feeling when another bomber in the formation exploded or fell away trailing fire. Unger, in turn, described what it felt like to attack those formations, the courage required to fly into that wall of tracers, the split-second decisions about when to break away versus when to press the attack, the guilt of shooting down bombers, and knowing you had killed 10 men, not one. The conversation revealed a shared understanding between former enemies that their respective propaganda machines had never captured. Both men had been terrified, both had done their duty as they understood it, and both had survived experiences that killed many of their comrades. What emerged from these conversations and countless others like them was a nuanced picture of the air war that statistics alone couldn't capture. The numbers showed that American defensive firepower had proven effective, contributing significantly to bomber survival rates and forcing German tactical adjustments. But behind those numbers were individual humans on both sides, crews who faced death on every mission, gunners who fired hundreds of thousands of rounds at targets trying to kill them, pilots who summoned courage to attack formations bristling with guns that could tear their fighters apart. The legacy of massed 50-caliber defensive fire extended beyond World War II into subsequent conflicts and weapons development. The Korean War saw B-29 superfortresses, successor to the B-17, flying missions against targets in North Korea while armed with similar defensive armament philosophies. The advent of jet fighters with higher speeds and heavier cannon armament shifted the tactical equation, but the basic principle of deterrence through visible firepower remained relevant. By the Vietnam War era, the defensive gun had largely been replaced by electronic countermeasures and escort fighters as the primary means of protecting bombers. The B-52 Stratofortress retained tail guns into the 1991 Gulf War, but these were vestigial remnants of a doctrine that had evolved beyond the massed gun paradigm. Modern air defense relied on stealth, speed, electronic warfare, and fighter escorts rather than the World War II model of bristling gun positions. Yet the lessons learned from the B-17's defensive firepower continued influencing military doctrine. The principle that protection of high-value assets justified significant weight and complexity penalties became foundational to later weapons systems. The AC-130 gunship, essentially a flying artillery platform, represented an evolution of the massed guns concept applied to ground attack rather than defense. The importance of combined arms, where multiple systems work together to create overlapping zones of protection, traced directly back to lessons learned over German skies. The industrial implications proved equally lasting. The American ability to produce millions of rounds of .50 caliber ammunition monthly while simultaneously building thousands of aircraft demonstrated manufacturing capacity that became a model for Cold War defense production. The standardization philosophy that made B-17 defensive systems so maintainable influenced post-war military procurement across all services. The feedback loops that eventually forced Bureau of Ordnance to acknowledge and fix torpedo problems created institutional frameworks that improved weapons development processes. Most fundamentally, the B-17's defensive armament validated the doctrine that strategic bombing could be conducted in daylight against determined opposition if the bombers carried sufficient defensive capability and operated in mutually supporting formations. This doctrine shaped Air Force thinking through the Cold War and influenced bomber designs up through the present day. The vulnerability problem never disappeared, but the B-17 program demonstrated that it could be managed through comprehensive defensive systems. The final word on what 8 Browning machine guns firing 800 rounds in 10 seconds meant to the men who faced that fire perhaps belonged to Hauptmann Franz Stigler, whose April 1944 encounter opened this story. Stigler survived the war, emigrating to Canada in the 1950s where he built a successful career as a commercial pilot. He maintained contact with several former Luftwaffe comrades, and their correspondence occasionally touched on their wartime experiences. In a letter written in 1967 to Heinrich Sturm, who had remained in Germany and become an aviation instructor, Stigler reflected on the defensive firepower question. He wrote that the technical specifications, rounds per minute, number of guns, hit probabilities, could be calculated and analyzed but never fully captured the psychological reality. The visible tracers created an effect that was as much mental as physical. Knowing that you were flying into that fire, watching it converge on your aircraft, required a type of courage that technical training couldn't provide. Stigler noted that he had been fortunate to survive long enough to develop the experience and judgment necessary to attack bomber formations effectively. Many pilots never got that opportunity, dying on their first or second mission before they learned the crucial lessons about timing, angle, and when to break away. The defensive fire was most effective against inexperienced pilots who either broke off too early out of fear or pressed too aggressively out of determination, both mistakes proving equally fatal. He concluded his letter with an observation that captured a fundamental truth about the air war over Europe. The bombers won not because they were invulnerable, thousands were shot down, but because enough survived each mission to continue the campaign. The defensive armament didn't need to achieve a 100% kill rate against attacking fighters. It only needed to impose sufficient cost that German forces couldn't sustain the attrition while American production could. That calculation, ultimately, determined the war's outcome more than any individual battle or tactical innovation. The Americans could afford to trade bombers and crews at rates that would have crippled German operations. They could sustain losses of 5%, 7%, even 10% on particularly bad missions, because their industrial system produced replacements faster than combat destroyed them. Germany couldn't match that economic depth, and no amount of pilot skill or tactical excellence could overcome the disparity. The 8 Browning machine guns that could fire 800 rounds in 10 seconds represented one small component of that larger industrial advantage. But they were the component that Luftwaffe pilots faced directly, the visible manifestation of American material superiority that literally filled the sky with tracers and metal. They killed German pilots, damaged fighters, forced attack modifications, and created psychological pressure that degraded combat effectiveness even when physical hits didn't occur. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.